Welcome to the LangChain Cookbook Part 2, where we're going to cover the 9 major use cases of LangChain. In Part 1, we went over the nuts and bolts of LangChain, but not necessarily the applications. My goal for this video is to inspire you to build. No one has expertise in your domain like you do. Really, I have no idea what you do, but I do know that you plus AI can come up with some really cool applications that can create value in the world. In addition to this video, I've also started a gallery of LangChain projects for you to get more inspiration from. Check out the homepage of this repository to see how other people are creating tools with LangChain. If you'd like to get your project featured, check out the contribution guide and throw up a PR. If you'd like to follow along with projects I'm building or AI trends that I'm excited about, you can check out my journey on Twitter. Last thing that I'll say is this video assumes that you've seen part 1 of the series. I'll be light on details about how these frameworks work and more focused on the application side. All right, let's jump into some code. My first goal of this cookbook is, like I said, inspire you to build. My second goal is to provide you a working understanding of the main use cases of LangChain in super easy to follow examples with code snippets. Now, if you want to know the nuts and bolts of LangChain, head over to the fundamentals video that's linked in here. This code can be accessed with a link in the description. First video, we talked a lot about what is LangChain, and I won't go through all these details again, but the TLDR is LangChain is a framework that helps you build applications powered by language models. So if you start working with your own language models, you'll quickly see that there's a lot of really complicated parts. And LangChain is a framework to abstract away those complicated parts and get you building faster. These are the 9 main use cases that we're going to go over. Now, I won't repeat them right here because we're going to go into them with some detail later on in the notebook. But if you'd like to jump to a specific section in the video, I put in timestamps and so you can check it out for yourself. Let's dive into the first one, summarization. All right, first thing we're going to do is insert our OpenAI API key. You can BYO language model if you want, so you can bring your own, but I use OpenAI just because it's nice and easy and well supported. Okay. Next thing I'm gonna do is I'm gonna make my display just a little bit wider. This is optional. You don't have to do this if you don't want to. All right, first use case that we're gonna look at is summarization. So this is a very common topic within LangChain, and the gist of this is to extract the important details or meaning from a longer body of text. Now, in each section right here, I'm going to put a link to a deep dive coming soon if I haven't found the right resource or I haven't made it yet. I'm going to link you to some examples, and then I'm also going to link you or tell you about some use cases that I've seen other people use this section for. So in the case of summarization, I've seen people summarize articles, transcripts, chat history, blah, 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 a whole bunch of really cool stuff here. Let's see how to do summaries of short text. Well, in this case, I'm going to import OpenAI. I'm going to import prompt templates, and then I'm going to create my language model. Now, the first thing I'm going to do is get my template going. Now, in this case, I wanted to show you an extremely easy example about how a summarization can be done, because then we'll build on top of that. All I'm doing is I'm making a prompt that has some instructions. Please summarize the following piece of text. Respond in a manner that a 5-year-old would understand. And then I put a placeholder right here for the text. And using a prompt template, what we can do, let me run that cell. And then what we can do is go grab some confusing text or some long text or whatever it is you want to summarize. I went and found this article from a science magazine online. And then what we're going to do is we're going to store that in a confusing text variable. And then I'm going to create my actual prompt by calling prompt.format and inserting my confusing text, which is going to get insert in the token that we looked at above here. And if we wanted to look at the final prompt about what this would look like, we still have our instructions, but now the confusing text is placed in there. And let's go ahead and run this to get our output and see what we can get here. All right, we have our output, and with a nice couple sentences, we get our summary. We could reduce this even further or make it longer. You just need to instruct your language model to use something different when you give it the instructions up at the top. Now, this method works fine, but it's pretty manual. And if we wanted to do longer text, well, we're going to need a different method for that. So I'm going to go ahead and import my LangChain packages again. But the new one this time is I'm going to have the load summarize chain. And this is going to be an easy abstraction for us that is going to be able to handle longer summaries. So now I'm going to load up a longer document. And just to show you, this is a Paul Graham essay. And I'm printing the first 285 characters. And you can see here, it's just kind of a standard essay that he did. Now, the important part is we want to see how many tokens are there in here. So there's 3,970 tokens, which this would fit inside of the token limit for most of your models that you're using, but just work with me here and pretend like it doesn't. So the next thing I'm going to do is I'm actually going to split this document up in different chunks because I want to get a summary of the mini chunks and then get a summary of the summary. Let's go ahead and run this. So now we have 4 documents instead of 1 piece of text. And so this one big file got split up into 4 pieces. Then what I'm going to do is I'm going to create a chain, and this is where I use the load summarize chain. I'm going to use the MapReduce method. Let me get my chain ready, and then I'm going to say chain.run and run it on the docs that we just split up. Great, now we have our output, and I've actually set it to verbose equals true to show you what's going on here, but LangChain is creating a chain for us that is going to sequentially call the different summaries on the different mini chunks that we want. And it's going to say, write a concise summary of the following, and then it gives us the text. And you'll notice that it'll do this 4 times to get our 4 summaries. So there's 1, there is 2, there's 3, and there's 4, and then it's going to ask for a final summary, a summary of the summaries of those 4, and that's where it says write a concise summary. So we got our 5th one, and then finally we get our article discusses, and it's a good amount of text for a summary here. The next thing we're going to look at is how to do question and answering using documents as context. It's an extremely common example for people to want to chat their documents, meaning you're going to ask questions to a book, or ask questions to a PDF or a transcript or whatever it may be. And the way that you're going to do that is you're going to take the important parts of your body of text and you're going to give those to your language model. And then you're going to ask questions for it. And the language model has the ability to reference the text that you shared with it and answer your question with it at the same time. Okay, so let's look at a simple example here. And again, we're going to do this manually first, and then we're going to build up to it. But the context that I'm sharing is going to be Rachel's 30 years old, Bob is 45, Kevin is 65. And then the question I'm going to ask is, who is under 40 years old? And the convention that we're going to do is, with our language model, we're going to pass our context plus our question, and that's going to give us our answer. Let me run that. And then we're going to combine them. So in this case, I'm going to do language model, context plus question equals the output. And then let's see what the output is here. Rachel is under 40 years old. And that is the question that I asked. And Rachel, yes, is the one that's under 40 years old. So this is an extremely easy example of context plus your question, but it gets complicated pretty quickly here. Let me run these. All right. And then the way that gets more complicated is the next method is we could use embeddings. Now, embeddings is going to be a vector representation of your different chunks or your different documents. And that's just a fancy way of saying your documents are going to get encoded into a big, long vector that is much easier to do similarity comparing on. There's a whole bunch of imports here, but basically you're going to import your vector store. You're going to import the way that you're going to retrieve your vectors. You're going to call your text loader, which is how you load up your text into some documents. And then you're going to call your embedding engine as well. Let's run that, and then we're going to load up a longer document here. I think this is Paul Graham's longest one so far, and it has about 75,000 characters in it. Now that's pretty long, and we won't be able to put that into our prompt, nor would we really want to, because a secret with working with language models is you only want to pass the most relevant context to your language model. You don't want to pass everything. Why? Well, because you want to reduce the signal to noise ratio. I like to offload my language models as much as I can. Okay. We're going to split up the docs using our recursive character text splitter again. And then now let's take a look at how many documents we have. So we have 29 documents with an average of 2,900 characters. So instead of one document and a big one, we have 29 documents that are split into smaller pieces. Let's create embeddings for them, and let's go ahead and throw them within our doc search here. Now that we have those embeddings, we're going to create our retrieval engine. So our retrieval engine is going to be the actual mechanism that goes and looks at the vector store, compares it with our docs, compares it with our question, and returns back what we need for it. So I'm going to create a query. What does the author describe as good work? Which I know this answer is in the essay there. We'll run that. Let's see what it says. And we get our answer back. The author describes painting, writing essays, and building things that will last as good work. Cool. The next topic we're going to look at is extraction. And extraction is the process of getting data that you want from a document. Some of the common use cases for this one is to extract user intent in order to insert a row inside of a database, or extract user intent in order to make a correct API call query. So it's whenever you want to pull data out of something and get it in a structured form. So first we're going to import our packages, and I'm going to use a chat model, which is why you see some more imports around message types. And then we're also going to import our structured output parser and our response schema, which is going to be an easy way for us to get the data that we want out. So the very first way, again, vanilla extraction, how we build on top of this is you will give a sentence with fruit names and then extract those fruit names and assign an emoji to them. Return the fruit names and emoji in a Python dictionary. So here I'm instructing the model as to how I want it to respond to me. Let's go ahead and run this. We give it fruit names, apple, pear, and this is a kiwi, just to give it a kind of more complicated example. And then we're going to create our prompt, which is our instruction fruit names. We're going to get our output, and then all of a sudden we get a Python dictionary of apple, apple, pear, emojis, etc. But I also printed out the type of this as well. And you'll notice that it's a string because a language model cannot directly output a Python dictionary. However, it can output a string that looks like a Python dictionary. And then what we can do if we did this the manual way is we could just call eval on top of that string, and it's going to output it's going to read that dictionary for us and actually convert it into a dictionary. So we get the same thing, but now it's a dict. Okay? However, that's not going to work for very complicated examples. And you'll notice that I had to worry about prompt engineering. I don't want to worry about prompt engineering. So I'm going to use a LangChain convention and use their response schema. So in this case, I'm going to define the type of response that I want the language model to return back to me in. And in this case, I want to extract user intent about a song and artist they want to play. So I'm going to say artist, song. I'm going to give a description about it so that the language model can help me out a little bit more. And then I'm going to create a structured output parser, which is the thing that is going to read the string output and get me what I need back. And one of the nice parts about this convention is that with this output parser, we can get format instructions, which is what we actually pass to the language model to tell it what we need. If we ran this, you can see that we get a string back, and it says the output should be a markdown code snippet formatted in the following schema. And then it gives us the schema that we need. The important part about this is I didn't have to worry about the prompt engineering. And the LangChain crew, they're a smart crew. They're going to make sure that this is going to be the most well-engineered prompt that I need to get my output out. So when you can, offload the prompt engineering to LangChain and don't worry about it too much yourself. Of course, unless you need to customize. I'm going to have a chat prompt template, and I'm going to say, given a command from the user, extract the artist and the song names. And then I'm going to give it the format instructions, which is the string up above. And then I'm going to give it the user prompt, whatever the user may say. Go ahead and run this. And then we format our prompt. And I'm going to say, I really like So Young by Portugal the Man. And let's see what this prompt would actually look like. So given a command from the user, extract it. This is the format instructions we saw before, and my query gets put on the end of that. And then what we'll do here is I'm going to pass this prompt to the chat model. I'm going to get the output, and let's see what it looks like. We have an artist, Portugal the Man, and then a song, So Young, which is pretty convenient that we can go use later down the line. And you'll notice that the output is not a string this time. It's a dictionary that we can use. And that is because the output parser read the string and returned us the dictionary, which is cool. For more advanced parsing, I would recommend checking out Core, which is a library by Eugene Yurtsev, and it is a pretty sweet example about how to get really complicated structured data out of a piece of text. Because the output of language models can vary drastically, evaluation is pretty hard to do. However, LangChain has some conventions for us that makes it easy for us to do evaluation on how our models are actually doing. The important part about this is you really want to be able to test your pipelines to see if there's any regressions or if your pipelines are still doing as well as you want them to, and evaluation is how we're going to be doing that. So we're going to do the vector dance again, and the new part that we're going to import here is on the evaluation.qa. And so we're going to have an evaluation question and answer chain. So LangChain will help us out telling us how our question and answer is actually doing. We're going to load in the long text that we had before. We're going to split the documents. I'm brushing over this because we already did it. We're going to embed those and do the vector dance. By the way, the vector dance is just what I call chunking, splitting, embedding, vectorizing, querying, etc., etc. And then let's make our chain to go get the information. Now, what I'm going to do here is I'm going to have a list of question and answers. This is a Python list with multiple questions. So for the very first one, which company sold the microcomputer kit that his friend built himself? And I went and I validated this answer myself. This is the ground truth answer, the source of truth. At least as much of a source of truth as you can be confident in yourself in. It's going to be HealthKit. And then for the second question, I purposely made it a hard question that I knew the language model likely wouldn't get. What is the small city he talked about in the city that is the financial capital of the USA? So this would take a couple of jumps to figure out what it is. The correct answer is Yorkville there. And then what we're going to do is we're going to call chain.apply on this list of question and answers. And you may be asking yourself, well, how does LangChain know what's my question, what's my answer within these? Well, the input key up here says question, and that means it's going to use this key in order for the prompt when it passes it to the LLM. So it's going to pull a question from here. Let me run this and we'll get our predictions back. Questions is not defined. Great. Forgot to do that. Let's run this. And when we get our predictions back, what we have is we have our original dictionary with our question and our answer, but now we get a result. And the result is going to be the output of the language model. So the microprocessor computer kit was sold by HealthKit. Yep, that looks good. The small city he talked about is New York City, the financial capital of the USA. No, it's not. It's Yorkville. So let's go and run this through our evaluator and see if we can get it, an incorrect or correct response. So I'm going to initialize my evaluate chain. And then I'm going to execute that chain and get graded outputs. The important part is that you pass it your question and answers, you pass it the predictions from up above, and then you pass it the keys that correspond to the ground truth, the question, and which answers came from the language model. Let's run this, and we get a label that is correct and incorrect, which is the right output based off of what we saw before. The next major use case that we're going to look at with LangChain is going to be querying tabular data. Now, this is super important because you're going to want your language model to talk to your database, or to talk to an Excel spreadsheet, or a financial report, or a financial model, or whatever it may be. And you're gonna have to query with tabular data. The way that we're gonna do this is we're gonna import from LangChain, and we're gonna import our SQL database, so it knows how to talk to the database. And then we're also gonna import our SQL database chain, so we can do some discovery about our tables and about which columns we need to use. We're going to get our connection ready. Now, I made a quick SQLite database here about the trees in San Francisco. We're going to get that one going. And then we need to initialize our DB chain. And this is where we're going to use the SQL database chain here. We're going to pass it our language model, and we're going to pass it our database. And I'm going to put verbose equals true here so you can see what's going on. Run this. And so how many species of tree are there? Well, I should say, are there in San Francisco? And let's see what it says here. So it's going to enter into the chain, and it's going to do a select count distinct Q species from SF trees. And it's going to tell us there's 578. Now, this is pretty cool, and there's a lot happening underneath the hood that I want to call out here. So not only did it find which table to use, because there's multiple tables in the database, it found which column to use. And yes, species is in the word, but I didn't tell it what the column name was specifically, but it was smart enough to go ahead and do that. It constructed the right SQL query, executed that query, got the result, and return the natural language response back to us. And you see here that the response back from the database was just 578, but it took that 578 and put it in a natural language response, which is super cool for us. And you can see how you can combine this with your output parsers, where if you didn't want a natural language response, you wanted a structured response, you could go ahead and do that here. Now let's go ahead and check this via pandas just to make sure it worked. So we're going to use pandas, set up our connection, query, read SQL query, connection close, and let's go ahead and run this. Yes, 578, that is exactly correct. The next topic we're going to look at is code understanding. So there's a ton of development happening, helping users query their own code or do code generation. And the way you do that is you basically load up your documentation in similar forms that we've seen beforehand. So again, these are all pretty standard imports, and we're going to do the embedding dance again. And what we're going to do is query the documentation of the fuzz, which is a personal indie favorite of mine, which helps find string similarities, not using language models. And what we're doing here is this function. We're just going to go through each folder and load up each file as a doc, and then we're going to put it inside a list of documents here. Let's take a look at just a sample to make sure we know what we're looking at. So we have 175 documents, and here's the start of one of the documents. You can see it's basically just pure code, and this is the documentation that we just ingested. Let's create our doc search. Let's get our retrieval chain ready, and then I'm going to ask, what function do I do if I wanted to find the most similar item in a list of items? Let's go ahead and run this and see what it says. You can use the process extract one function from the fuzz library to find the most similar item in a list of items. Nice, that looks cool. But what if I just wanted the code? Well, it's as easy as just altering your question that you're asking the LLM. Can you write code to use the process exact one function? Only respond with code, no other text or explanation. And what we get is process extract one, query, choice one, and choice two. That's cool because I can go ahead and take this and put it right inside my code. The next topic we're going to look at is when LangChain helps facilitate a language model talking to an API. So the only non-standard thing we're going to import here is going to be the API chain. And what I wanted to do is show an example about how API documents are read, and then the language model can understand which API call it needs to make. So I wrote some pretty scrappy documentation here that is sloppy on purpose. So I put in a base URL, and we're going to go query restcountries.com, and then I put in 2 API endpoints here. And I also put in woo, this is my documentation, just to show you there is no standard format on what we need to do here. And I'm going to create the API chain. I'm going to pass in the language model, the docs. I'm going to set verbose equals true so we can see what's going on. And then my first question is going to be around this first endpoint, just to show you how I can switch up here. And then, so tell me information about France. It's going to make this request here, and it's going to insert the right token that we need, and then it's going to get the API response back. Now, this is a bunch of gobbledygook garbage. However, it can interpret that response and give us back a natural language answer here, which is pretty cool. So France is officially assigned independent country located in Western Europe, etc., etc. Nice. But what if we asked a different question? Can you tell me about the currency COP? I wanted to query this second endpoint here. And you'll notice that I'm still just calling chain new.run. I haven't switched anything else except the query that I put in here. But the language model is smart enough to understand, hey, I need to use a different endpoint. So I'm going to put in COP to this endpoint here. We get the response. The currency of Colombia is the Colombian peso COP, symbolized by the dollar sign. Nice. The next topic we're going to look at is chatbots, and everyone and their mother is doing chatbots right now because not only are they easy to build, but they're pretty cool to use and provide to your users as well. The new import we're going to bring in here is going to be the conversation buffer memory. Now, the important thing to know about chatbots is it's just the same tools that we've been using thus far with the addition of one interesting one, which is memory. Now, memory is when you remember what were the previous calls that you made to your language model beforehand, so you can keep context about a conversation. And if you didn't have memory, well, it would kind of just be question and answering with that wouldn't be very helpful to the user in a chat setting. So this conversation buffer memory, that's going to keep a running list of messages that we've sent back and forth with the AI. I'm saying, template, you are a chatbot that is unhelpful. Your goal is to not help the user, but only make jokes. Take what the user is saying and make a joke out of it. We put a placeholder for chat history, which is going to be where our previous messages are going. And then we also have human input, which is going to be the most recent query that the user submitted. And then we're going to have the output from the chatbot. Let's run this. It not defined. Great. And then what we see here is I've stored within a memory variable, we have the conversation buffer memory, and the memory key is going to be the chat history, meaning this key is what matches within your template that you're working with here. Then let's create our LLM chain, and we're also going to pass in memory here as well. Go ahead and run that. And then the first thing I want to ask is a pear a fruit or a vegetable? And let's see what it says. Here's the template that I put in beforehand. It has, is a fruit, a pear, or a vegetable? Neither. It is an imperative. So there's the joke because I told it to not be not be helpful. So then where the memory piece comes into, I say, what is one of the fruits that I first asked you about? Let's run this. Let's see what it says. And the cool part is you can see it has my question that's in there, and it has its response, and then it has my most recent question. You wanted to know if a pear is a fruit or vegetable, but I'd say it's a I'd say it's a comparative. Not a very good joke, but I think GPT-4 would do a better job at this. That's chatbots. There's a lot of different types of memories, and it can get complicated pretty quickly here, but I've put a link to the documentation that you can go and check out yourself. And then the last topic that we're going to talk about here is agents. Now, agents is one of the most exciting places and one of the most complicated topics within LangChain and language models in general. Agents are the decision makers that can look at data, understand what the next action should be, and then go and execute that action with a series of tools that they've been given access to. The interesting imports we need to bring in here is going to be the load tools and initialize agent. Now, the tools that we're actually going to load are going to be the Google Search API wrapper and then the text requests wrapper. And this is going to be a way for us to give our language model access to the outside world. Now, if you want to sign up for the Google Search wrapper, you need a few API keys, but I put links for those in there as well. Let's initialize our language model, and then we're going to put our tools into a set of variables. So here we have a search and we have a request as well. Then we're going to make a toolkit, which is kind of like a tool belt where you put your hammer and your nails. Well, now you need a toolkit with your tools. The first tool we're going to use is our search tool, and we're going to give it a description. This description helps the language model know when it should use that tool over another one. And then we have our requests used for when you need to make a request to our URL. Cool. Then we're going to need to initialize our agent. We're going to pass in our toolkit, our language model, the type of agent that it should be, so that the type of decisions or how it should be making decisions. We're going to set verbose equals true so we can see what's going on underneath there and return intermediate steps. So we're going to ask a question to our agent. What is the capital of Canada? And let's see what it does here. So it says, I need to find out what the capital of Canada is. Yes, correct. And the action it's going to do, or the tool it's going to use, is use the search tool that we had up above. And it's going to input to Google, because it's using the Google one, what is the capital of Canada? And it's going to get a response back from Google, which is the observation that it saw. And then its thought, which is basically its how it processed that response. Ottawa is the capital of Canada, and we say Ottawa is the capital of Canada. Correct. Now, with our agent, I'm going to say, tell me what the comments are about on this webpage, And I'm going to pass it the URL of a Hacker News article, and let's see what it says about that. So the first thing it's going to do is it's going to say, I need to find out what the comments are about. It tries to use the search tool, and it searches for comments on this URL, but no good Google search was found. Okay, so then it's like, you know what, I should try to access the web page directly, which is the correct action it should be doing. And it's going to say, it's going to go to the request tool, it's going to put in that URL, it's going to get the HTML back, blah, 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 blah. And it's going to say the comments around OpenAI's embedding an API, GPT-like LLMs. Sweet. Our agent had to reason through the different steps that it should take. And that's the cool part about agents, but it's also where it can get kind of complicated. And Sam Whitmore on Twitter actually said, in her experience, she's seen that agents are successful about 85% of each loop. So that means that each time you're running through an agent, it might not actually work. This is an active area of development and a space that I'm going to be watching very closely. Wow, you just made it all the way down to the bottom and to the end of this video, and I congratulate you. Where do we go from here? Well, it's time to build. And as AI matures, the use cases are going to keep growing and growing. So please let me know what else I need to add to this notebook here. Now, again, if you want to check out examples about LangChain projects, head over to the gallery in this repo. And like always, if you have additions to this notebook as well, please check out the contribution guide and throw up a PR. Thank you, crew. We'll see you later.